Hello and welcome back. And in this video, we're going to be looking at our stack implementation using LinkedList approach. Okay, so let's go ahead and get started. So I'm going to create another file here. And if you recall from LinkedList section, we need something called node. So we're going to create our node class. And node class is very simple. Basically, just create a node with data and your next pointer, which is going to point to node. And for as an initializer or as a constructor, we expect to be initialized, or node expect to be initialized by the data. Okay, so this is our node class. Now we're going to create our stack.fit file. And here, what we're going to do is first create our class stack. The stack is going to have, first of all, head. Okay. Which is going to be of type node, and it's going to be nil. We are also going to keep track of the length of the stack. So we're going to create a length variable. Okay. And when we initialize our stack, we're going to initialize our length. Okay. Now come to basically the basic operations of stack. So once again, first of all, we're gonna put all the functions that our stack supports in this, the signature in the file. So we're gonna say we support push. We support pop. Pop is going to return a node optional, so we can return nil as well. And we're going to have p. And we also are going to have is empty. Just going to return a boolean. Okay. So is empty is simple. So let's go ahead and implement that one. So we're going to return if length is greater than or less than equal to 0. So if it's less than equal to 0, is empty is going to be true. Otherwise, it's going to be false. Okay. Now let's go ahead and take a look at our push operation. So for the push operation, what we're going to do is we're going to say we're going to create a temp variable, and we're going to say assign head to the temp. Okay. And basically, we want to keep what's the current head there is. Then we want to create a new node and assign that to our head. So we can simply say data needs to be pushed and create a new node and assign that node into the head. And now we have our new head. So basically, we have inserted our element or data at the top. We want to make sure that head.next points to the old head, the old head that we have cached into a temp. And that is your push operation. So basically what you're doing is you're appending an element. So let's say if you had 1 and you want to insert, you had 2, you want to insert 3 in there. So your current head is 2, right? So you're going to, so this is going to be your current head where it's going to be pointing. So you're going to say, hey, cache this memory location, right? Create a new element called 3 and 3.next. Now, this does not do the correct representation, so let me do it. Pointer-based approach is a little bit different. So let's say you have stack where you have 2, which is pointing to 1. So 2 is at the top, right? And now you want to insert 3. So you're going to create 3 here. And next operation you're going to do is you're going to say 3 dot next is going to be the existing, the old head. So old head was 2, so this is the memory location that we know of. So we're going to take that 2 and basically assign it as the next element for 3. Now, eventually, because you are pointing at 3 is pointing at the memory location of 2, and 2 already points at memory location of 1, so your link is restored now. So your top of the element becomes the new element that you have inserted, and your remaining list stays like that. So if you look at this closely, this is actually exactly like linked list, right? So basically, stacks are linked lists. It's just like, limited operations that you can do on that. Okay, so let's work on pop now. So pop is going to be where you want to remove that head element, and then basically whatever the next element to the head is, you're going to make that as the current head. So that's what we're going to do. We're going to say temp is equal to head, and you're going to say head is equal to head dot next, right? And then you can simply say return temp, because now temp does not point to anything. So, right, that's actually something that you can return, and your new head becomes the next element there is in the list. Okay, so that becomes your new head. Okay, while we are doing all this, let's go ahead and keep a count of length as well. So we're gonna simply say length plus equal 1, and this is going to be length minus equal 1, and we simply going to do another check here. So for length, if it's less than equal to, or if it's less than 0, right, it can go in negative, then assign the value of length to be 0. Otherwise, keep it as length. Okay, so that's your pop operation. Peek operation is once again easy. You simply say return head. Okay, that's your peek operation. And with that, our stack is complete. So we can simply change this to stack or stack and run this. And you notice we have a few things. So it says print stack dot pop. So we know that it's going to be something here. So we can simply say data, of course, unwrap that, and head dot next. So head dot next is going to be an optional. So there we go. We have our stack. We are inserting 5, 4, 3, 2, 1, and we are getting 1, 2, 3, 4, 5. So that's your linked list based approach to build stack. Hope you guys enjoyed this video. Thanks again for watching. I'll see you guys in the next video.